Okay, welcome back everyone. In this video, this is an example problem of how to use the electric field of a point charge. And so this is problem number 58, on page 533. And we have two charges of 4.0 microcoulombs and 9.0 microcoulombs. They're 30 centimeters apart, and we want to find the place on the line joining the charges where the electric field will be 0. Okay, so the first thing we want to do is think about this conceptually, and we can kind of divide our space into three regions: in between the two charges, and then to the left and to the right. And remember that when we calculate the electric field, at any point in space, we plop down an imaginary positive test charge, a very small charge. And then we say, okay, what would the point charges that we have, the 4 microcoulomb and the 9 microcoulomb, be doing at that point? And so what we end up with is, let's call this charge 1 and charge 2. So we would have an electric field E1 coming from charge 1, pushing away, right, because it's positive and positive would repel. And then we would have an electric field from E2, which would also be pushing away. And it might be less, I'm not sure how much less. Even though charge 2 is greater magnitude, it's further away. But in any case, they point the same direction. So can the electric field be 0 to the left of the two charges? No. And for the same reason, you can't have the electric field being 0 to the right of the two charges. So we can narrow our search by looking in between the two charges, and you might guess that it's probably going to be a little bit closer to the 4 microcoulomb charge than to the 9. So we can mark that point, and if we know that it's 30 centimeters between them, we can call one of the distances x and the other distance 0.30 minus x. So I want to do this in terms of meters because everything else I have has meters. So what this means is that if I put a positive test charge, the field from the first one, E1, will be pointing to the right, and the field from the second charge, E2, should be equal and opposite, pointing to the left. In other words, the magnitude of E1 is equal to the magnitude of E2. Okay, so if I have a negative sign for my charge, I don't really put that in this expression because I'm using my diagram to figure things out. Alright, so this means that K Q1 over R1 squared, that is the field for a point charge, which you learned in a previous video. And for E2, K Q2 over R2 squared. And we can see from the diagram that R1 is going to be equal to the distance x. So I have K Q1 over x squared, and R2, so K Q2, R2 is going to be 0.3 minus x quantity squared. Okay, so at this point I can cancel out K, which is nice. Q1 is 4 microcoulombs, and Q2 is 9 microcoulombs. And from here, I'm just going to solve this expression. Oh, microcoulombs cancels out because that's 10 to the negative 6 over here and 10 to the negative 6 over here. So that makes my calculations a lot easier. I basically have 4 over x squared is equal to 9 over 0.3 minus x quantity squared, which is a quadratic, but it's not horrible. And so to solve this, we can cross multiply. And don't make the same mistake that I did at one time. 0.3 squared is actually 0.09, not 0.9. And so then we just go ahead and do math. And I think it's important for you to see this process because you'll have a couple problems like this, and keeping things organized is really important. I'm going to move everything over to the right side and write it in the form of a quadratic equation. So I have 5x squared plus 2.4x minus 0.36 is equal to 0. And so I'm going to have x is equal to negative 2.4 plus or minus square root of 2.4 squared minus 4 times 5 times negative 0.36, and that's all over 10. So that's negative 2.4 plus or minus 3.6 all over 10. So this is going to give us two answers, but only one of them is going to make sense. X could be equal to negative 2.4 minus 3.6, or basically negative 0.6, or x could also be equal to negative 2.4 plus 3.6, which is basically 0.12, and these are meters. Okay, now if we look at our diagram, x is right here. So x is starting at the 0 point, if you will, at charge 1 and going to the right. So 0.6 or 60 centimeters to the left, negative 0.6 that is, that first answer is just not going to work. And the second answer, 0.12, that's what we want. Okay, so it's going to be 0.12 meters from Q1, which is 0.18 meters from Q2. And the interesting thing is we can check this. Q1 is basically 4 over 12 squared, and Q2 is 9 over 18 squared, and I'm pretty sure that when you do that, you're going to get the same thing. So on the one side we get 4 over 144, and on the other side we get something that reduces to 4 over 144. You have to kind of play around with the numbers a bit, but it does work out. So there you go.